Oh shoot. Okay, I'm going to do the first several. Make sure we're all on the same track. Now, up here, a second ago, I had, you can simplify this, number one. Remember what I said, like ln, logarithms, you can use properties of logs. You can divide, you can factor and kill. Algebraically simplify the function you're given if you can, because very often the derivative will then be easier. So most of you guys, I think, did quotient rule in this, but you could have x squared over x to the 1/2 minus x over x to the 1/2, and then simplified, and then it's just a bunch of power rules. Much easier. But let me go ahead and attack this with quotient rule. So if we do quotient rule, it'll be through the top times the bottom. How do we keep going? Minus. Yeah, the top times the derivative of the bottom, which will be all over square root of x squared, which is x. Okay, cool. And then you just multiply through. So you'll get... Now, I like somebody multiplied the top and bottom by square root of x, which is an awesome idea, because that would kill this. Right? You guys see that? Pretty much always look for that. When you have radicals in your derivative, especially when it's a quotient, you look for, if I multiply by x to the 1/2, guys, on the top and bottom, that is going to complete itself. It's going to become a whole x. And that is going to go the hell away. Do you guys see what I'm saying? It's almost always going to happen with derivatives because of how they work. They're based off of going down by 1, so they're going to be related to one whole. I don't know if you guys saw that. So I can multiply. If I multiply top and bottom by x to the 1/2. Let's see what I get. I get 2x minus 1 times x minus x squared minus x plus 2 times 1/2. That's all over x to the 3/2. And then this looks a little bit better. 2x squared minus x squared is x squared. Minus x minus negative x is gone. Let's see, negative. Oh, there's a 1/2 in there, Jeff. Don't make it too simple. Oh, I could have multiplied by 2, but screw it. It's too bad for me. 2x squared minus x squared plus x. Let me see how it is. Well, let's bring the 1/2 in there at the same time. 1/2. 1/2. Minus 1. All over x to the 3/2. That is beautiful. Now minus 2x squared minus x squared. 1/2 x squared. There it is. Cool. Plus 1/2 x minus 1. Cool. Get your like terms together and see if we can simplify. Let's see, 2x squared minus 1/2 x squared is 3/2 x squared. Minus 1/2 x minus 1. Alright, so any way you do it, you should come out with 3/2 x to the 1/2 minus 1/2 x to the negative 1/2 minus x to the negative 3/2. Crazy. Now, if you would have, from the beginning, if you would have simplified it, it would have been x to the 3/2 minus x to the 1/2 plus 2x to the negative 1/2, and then the derivative, 3/2 x to the 1/2. You guys with me? Minus the 1/2 comes down. I get a 1/2 minus 1 x to the negative 3. Same thing, but look. Efficiency is always good with derivatives. So again, I can't stress enough how algebraically simplifying it, if you can, is an awesome idea. If I would have done this, then that would have disappeared. That alternate way would have been gone. But when the bottom is a single term, hell yes, I'm going to break that thing up. I don't want you to hate anything we do in here, but if I had to pick something I hate personally, it was quotient rule. I always hated it. That's why I never used it. And here, I don't have to use it at all. There's no reason to use it because I can make it not a ratio very quickly. Okay, there you go. Now, part B, I don't know if you noticed, looking at number 2 references part B's function, right? So it seems to be sort of important. Part B is why people die in Math 178. Do you know what Math 178 is? No. Math 178 is Math 180 light. It's like calculus without the theorems. It's supposed to be. But people who take it don't have to do a lot of math, and therefore very often their algebra is very weak. And so they can't factor. Alright. So you guys, where are you guys at? We'll get there in a minute. Alright. This one, did I put enough things down? Yes. You don't have to know ahead of time. You never have to know ahead of time how many times you got to use chain rule, or even if you have to. What's the main thing happening up here? Product. So it's product rule. That's all I got to know at the moment. That's all I got to know. So then y prime is 2x minus 5 to the 7th prime. Oh, you're going to need more room, Jeff. I'm going to need a bigger board. Bigger board. You guys got this here, right? It's over there too. Let's see, blah, blah, blah. And then plus, leave the first dude alone, derivative of the second dude. That gets you started. Writing the rule down tells you what you actually have to do. Guys. Right, writing the rule down tells you what derivatives you actually have to take. So what's the derivative this year?
7 2x to the 5th times 2 to the 6th.
Yeah, times the chain rule comes into play, right? Good. And there's no more chain rule. How do I know I'm done? Because this is the innermost function. Once I do its derivative, I'm done with the chain rule for that part. Times this guy. Plus, leave this guy alone. Times, how do you take the derivative of this guy? 5 fourth times negative 4. Because that's going to be the derivative of the inside, right? Now clean it up a little bit. So I got 14, 6 of these, and 5 of these, minus 20, 7 of these, become a minus 5. And 4 of these. So now my brain should automatically say GCF. Just screaming GCF. Please, dear God, do not write this 6 times. Holy shit. Most of the time in this class, the most interesting places on a graph, or the place that denotes the change in something, is going to be where this happens. And that happens where? When the slope is 0. Now, if the slope is 0, is it definitely going to be a max or a min? No, because it could be this. So just because the slope is 0, just because the tangent line is flat at that point, does not guarantee that it's a max or a min. It might not actually turn. So then we have to have tests that we'll learn later about how do you tell if it is a max or a min. So how do I factor this? What comes out? 2. Good. How many 2x minus 5s? 6. How many 3 minus 4x's? 4. So then I'm left with 7 times one of these minus 10 times one of these. Let me put it up here. So I got y prime 2 times, I took out 6 of these bad boys, 4, become a 3. 4 of those, right? Yeah. And then, now watch. So then you distribute, you get 21 minus 28x minus 20x plus 50. Sound correct? This happens almost all the time. When you start with a product of polynomials to powers, you're going to have repeats. It's guaranteed. Right? Because the same thing is still there, just to a 1 less power. So then GCF to GCF it. And then the inside just got to clean it up a bit. Bless you. What do you get here? You get 71 minus 48x. Sound right? So thinking ahead to number 2. Number 2 says find where this function has horizontal tangent lines. Oh, sorry. Did I make a mistake?
So would it be 5 half?
Wait. Is it all right? All right. So then what do I do with this for number 2? Set equal to 0. So where is it going to equal to 0?
5 halves.
5 halves.
4 thirds.
Who to what?
I mean, 3 4 4.
I love you guys. You see the numbers, you can see stuck. You got to think about what you're actually doing. And then finally,
748.
yeah, 71 over 48. You're not going to divide by the number in front of the variable. That's going to go on the bottom of the answer.
So did you want the points or just the slope?
So what exactly did it say on that number 2? Find where that has horizontal. So you can say at those locations. Or you can answer, you can actually find the points too, but it didn't really specify. So in general, when I say where does something happen, that's an X answer. When I say what happens there, that's a Y answer. So if I said where is the profit maximum, you would give me an X value, whatever that is. So that's the price or whatever. And if I say what is the maximum value, that's the output. So if I said what is the value here, what would you do with that? What would you do? Plug it in where?
The original function.
Original. If I plug it in here, of course, I'm going to get freaking 0, of course, because that's where it came from, right? I got to plug it into the original and see what the function's doing there. Maybe. So this has horizontal tangent lines at these x locations, at these x values. So it could be maxes or mins, we don't know. In the future, we're going to call these numbers critical numbers. Actually, we're there. We're in the future now. Holy shit. Just wait, and then it's there. How do you travel in the future? Just stand somewhere for a while. Okay. C is the easiest problem on here. If anybody got 2 pi in there,
0.
It's 0. The derivative of any constant is 0. And pi squared is just a constant. Alright, let's see. Has everybody got what they want from there? It's so easy to miss something. So I hope you understand that writing the rule will help you out. But it will also help me, because if you make a mistake somewhere and you didn't write the rule out and you're hiding somewhat, I can't tell what the hell happened. So here I know you know the rule, you just made some little 2 times 7 is 15 or something. All right? I can live with that kind of mistake as long as you don't really believe that. All right, so what about 1D? Yeah, it's a nice normal product rule, right? There's no functions inside of anything, so there's no chain rule in here at all. So how does that work?
X prime cosine plus cosine prime times x.
I like it. X prime is 1. This is understood to be the derivative with respect to x, right? So this would be 1 cosine x.
Minus.
Good, because the derivative of cosine is negative sine, so it would be negative x sine x. That's y prime, bam.
Negative x sine x can be written as negative sine x.
No, we're doing that. So sine x, this is inside, this can't possibly get in there. Do you know what I'm saying? I mean, it just can't. So if I had sine 3x, don't take the 3 out and say, well, that's not bad. No.
That's only to the power increase x cubed, right?
Well, this is sine 3x.
Yeah,
So this would require a chain rule, right? So some people try to get around the chain rule by just taking that out, but you can't
I'm
do
saying
that.
if it were sine of x cubed, then you can put the 3 in the front, right?
No. So several things.
Yeah, never mind.
Okay. All right. So E, I think, is the youngest one on here. Part E is just a little bit of stamina problem, and just to see if you have confidence in where to stop. So the first thing I would do on this is obviously rewrite it a little bit. So that whole thing is inside of a fifth root.
Can you change the sine cube, take the cube out, make it sine?
Sure. That might not be a bad idea. Just remember that 3 is on this whole thing, right?
No, but can you also take it out one step further? Make that whole expression to the 3/5.
Yes, sure, of course. Totally. So that can come out there. I like it.
That's way easier.
Didn't even think about it. Since this whole piece inside is cubed, this can become this whole thing to the 3/5. I like it. Cool. So that's just this idea of that. How do I write that as a fractional power? Roots go on the bottom like on plants. Powers on the top because they're powerful. So that would be x to the 3/5. So now I want to do the derivative. It's a little bit easier to look at.
Yeah, 3/5 from the sine of 3x squared minus 2, and then cosine.
Negative
Negative 2/5.
See, that's one of the most forgotten things. And it makes things so much easier if you had to do more after this, but everything after this would be wrong. It sucks. So you got to immediately take that down by 1. When you take a power down, it can't just go away. It's got to go down by 1. Now the first chain is going to be the
Cosine.
And let me just write it here. The most careful you can be for yourself, so you don't have to think ahead to know when to stop. That's the inside function, so it gets a turn. When I do its derivative, it has an inside function, so that inside is going to get a turn. I don't have to know that right now. I don't know shit about that. And when I start to take its derivative, I'll notice that. So you get 3/5. There's some way to just go repeat what it says.
Cosine.
Good. Cosine.
3x squared minus 2. Inside cosine.
Yeah, what's the derivative of the inside?
Oh, 6x.
And I know I'm done because there's nothing else inside what I just did. That's how I know when I'm done. There's no other inside function on the function I just took the derivative of. But I always get somebody who does this. No, there's no reason. There's nothing here saying take the derivative of this. Nowhere. Do you guys see that? I'm trying to figure out a way to say that. Why did I do cosine? Well, let me see. Why did I do 6x? Because it's inside a function I just took the derivative of. So when I take this derivative, is there a function inside of this? No, inside of this. Is there a function inside of this function?
Oh.
Inside of that?
No.
No. So when I take its derivative, I'm done. There's no more inside functions. Now, of course, to clean this up a little bit, I just pull the 6x out front with this, and it'll be 18x over 5 times sine. I could pull this down, but it doesn't really matter.
Oh, I see. Okay, nice.
Oh, boy.
Do you want to see something?
Yes. Sorry. Yes.
So by having a negative 2/5 above the sign, because I did it the other way, I had it multiplied by sine squared, so it's the same thing, right? Wouldn't it be the same?
Oh, there'd be a sine squared here, sure. Yeah. And that would be to the negative.
Well, I mean, it'll be negative 4.
Get a little weird. It would simplify to the same thing it has to.
Yeah.
Wait, how can you simplify that?
If you did it the other way, we'd have to do it the other way to see. Let's see. Just about out of time. Just look ahead for a second. We'll finish this up next time. We already did number 2. All we got left is F, which of course you use course roll, and G. The main thing with G is just. The main thing with G is chain rule. And then inside the chain rule, there'll be a product rule.
Yeah.
All right. Yay, Jeff.
So tomorrow's a quiz.
Yes, tomorrow's a quiz first thing. Just on 3, 1 through 2.
So no chain rule.
Three plus.
No chain rule.
No chain rule.